Hey everybody, this is Alex Merced from alexmercedcoder.com, and in this video we're going to be doing more OCAML. Okay, so basically again, the lineage goes, there was a language called ML, machine language, then there was CAML, I forget what the C and the A stands for, and here we have OCAML, which is I think object-oriented CAML, so it has classes. And then you have F sharp, that's kind of a version of that, but with Microsoft support. And I think there are other languages in the ML family, and I think Haskell is sort of very similar. Um, just to kind of get an idea of the lineage of this particular sort of branch of programming languages. So today what I'm going to do is focus on just some other things we haven't talked about yet. Um, so first off, what I want to do is talk about a variant. So a variant is like another custom type. So last time we talked about records, where you can create a custom type where they have like different properties with different names, and you type those names. A variant is more like creating a list of options. So for example, if I were to create a type, and again, whether it's a record or a variant, you're using the keyword type because you're creating a type. It's for purposes of checking actual future data you're going to create and making sure that your data conforms to what you want. Now, if you've done JavaScript, Python, or Ruby, or PHP, where typing isn't required or isn't the norm, typing can be really, really annoying, and really, really slow things down. But there's a benefit to it. Okay, the benefit of typing, and this is why TypeScript and JavaScript is getting so big, is that allows one, it makes it harder to have errors in your code because you have sort of two main lines of defense. Okay, one, because you type your, well, actually three lines of defense. One, by writing out your types, like this variable is supposed to be this variable is supposed to be that, like this is a string, this is an integer, your IDE can catch those errors. So basically, an example, let me just create this type. So we'll call this like traffic, like a traffic light. And what it's going to equal is either, and then we use these pipe symbols to give the different options: red, yellow, blue. Okay, I think I need to get rid of that last pipe. There we go. So basically what this is saying is that anything that is basically specifying red, yellow, or blue is of type traffic. So if I were to declare a new variable, so, well, not a new variable, let's say declare a new let binding, because again, there's not really variables in OCaml, because variables kind of imply mutability. So really what we're doing is we're binding an expression to a label, and technically that value never gets changed ever. Okay, once I say that, you know, my binding, we'll call it, equals something. So right now, if I were to just say my binding equals 5, 5 is an integer. So it's going to dynamically type it, meaning since I assigned an integer to my binding, it must imply that that's what I meant to do. So see, it knows it's an integer. If I were to assign it the value red, it'll just imply that I meant to assign it the value of traffic. So see there, it says type traffic. That's pretty cool. Okay, so your IDE is able to pick up on these things, meaning your editor. Okay, but now let's say I do this. Let's say I make the 5 again, and then I wanted my binding to be traffic. I wanted to be of the type traffic. Okay, I can just do this. So what I'm doing here is I'm saying this value should be of this type. And see, now my IDE is giving me an error that's saying, hey, this is not what you're telling me this is supposed to be. And that's a problem. And now I know that, and I can fix that. That's the beauty of typing. It's a lot of extra work, but you catch your errors much quicker because your IDE is just going to sit there and say, yeah, you can't do that. On top of that, when you try to compile the code, it'll give me an error. So let me actually try to compile this code. So let me open this in the terminal. Again, that'd be Dune build, and see I get an error. So if I didn't notice that my ID was screaming at me, or my ID didn't have that feature, the compiler would still yell at me and give me that very specific, hey, you meant for this to be traffic and you gave me an integer, I'm complaining. And then the third thing is other people can read your code. Okay, when I read your, so if you wrote this and I'm reading your code, I can be like, oh, okay, you meant for this to be this. Okay, that doesn't match. Okay, or you pass me a function, or you write a library of functions that I'm going to use for a different part of the program. Again, the fact that you were able to type all those functions allows me to be able to easier use those functions because my IDE can tell me exactly what the function is expecting to return, what the arguments are supposed to be, all sorts of good stuff. So that's sort of like why typing matters. Not just in OCaml, but in C, in C++, in Go, in Rust, in TypeScript, and nowadays you're actually starting to see new capabilities for typing in Python. I'm not sure if they brought typing yet to Ruby. They've added typing to PHP, but in those languages it's kind of optional. It's like if you want typing, typing is there. So that's all pretty cool. Like more people are coming around to the idea that even if it's a dynamic interpreted language like Python, Ruby, and JavaScript, that typing is desirable. It makes it easier to work with larger code bases as larger code bases are existing in those particular languages. Now, functional programming languages like OCaml tend to have typing right out of the box. It tends to be a very big part of how it works, etc. Okay, and then also another nice thing about typing is that it allows the compiler to if it knows the more it knows about what you're doing, the more it can more optimally compile your code and make sure that it's giving you the sort of the most efficient version of the underlying machine code or binary possible. Because it can be like, okay, well, you are declaring a array of 5 elements, so let me set aside the memory for that. Instead of you saying, like in JavaScript, I'm declaring an array, I have no idea what size this is going to be. So you have to use maybe less efficient data structures like a linked list versus an array of congruent memory, because, hey, we need to make sure that we plan for every scenario. So just to give you some context there. So I can say, okay, this is red, and see now it doesn't complain anymore because it sees that I've assigned the right type to the variable. So that's what a variant is. So in a variant, I'm declaring sort of different types. Okay, so whether it's a record, whether it is a variant, you're just declaring a type, and you can use that type to specify what values or what does a function return. So for example, I can create a function. So let's say here I say I let stoplight or traffic check. Let's just call this traffic check, and this is going to be basically this is going to be a function that takes in a number. So it's going to have one integer called int x. Actually, it should be like x int. Okay, and then this function returns traffic. Okay, so that's my signature. So I'm basically saying this function takes in one argument of type integer, and it'll return me a thing. Okay, and then we can do something like an if statement. So we can be like, okay, if x equals 0. Okay, it doesn't like that. Oh, it's just because I haven't returned the number yet. X, then then I don't think I can use a return keyword here. Yeah, it's just return red. Else if x equals 1, then yellow, else green. Okay, let me just read through this. Okay, if then red, else if we have a type traffic, the constructor green does not belong to type traffic. Oh, I wrote blue. blue's not a traffic light. So write green, and there you go. Okay, so see, this is this function then check C. Like my ID doesn't complain because regardless of whatever possible scenario, it's going to return red, yellow, or green, one of the different traffic colors. Okay, and I'm using an if statement. Cool. So that is that. So basically that's how you would type a function. So again, here's the function name. Here are the different argument types. Okay, and then what I could do is I can even make it a named argument. So I can do something like, I use the tilde, and we're gonna say traffic light status. Let's see what it's complaining. Unclosed waiting type. Let's see if I get rid of that. And unused variable int. Error unused variable light. Oh, okay. So then basically, now in this case, I made it a named argument. The tilde makes it a named argument, meaning when I use the function, I actually specify the name of the argument. I don't just. I should have probably shown you both examples, but we'll come back to that. Okay. Cool. Let's see if it lets me type it now. Error unused variable int. I think it's a different argument. And if I do that, okay, so basically it's like so one or the other. I can have a named argument. I'm sure there's a way to type it, but I'd have to go back and read up on it some more. But basically, in this case, I could use the function and be like let, and I do traffic check, and I say light. I think I actually pass it kind of like with the curly brackets. Light equals 0. See what it doesn't like about that. As a type traffic, but the expression was expected of type unit. Oh. Traffic. Got it. Whenever you use a parentheses, it's expecting a unit, so I gotta call it something. So we'll just call it cheese, and I want it to return traffic. That way it doesn't complain that I'm using this function. Committed in the application of this function. Light equals 2 or 0. Type int. Why is it a type bool? This type bool, but an expression was expected of type int. Committed. Well, let's just change this back to explicit. 1 second. So we'll just say light equals int. Okay, which means in that case I just pass a 0. I don't have to actually give it a name because it's no longer a named argument. And see, that works. Traffic light. It's like, okay, it all matches. And that's all fine and good. Okay, there's a way to do the named argument thing. I have to go read up on them a little bit more so I can execute that a little bit better. But you guys get the idea. So what have we learned here? We've seen that we can create variants, define particular types. We can check those types. We can use colons to type things. Now, the one thing to keep in mind is that like when you have like custom types, you have to create like custom print functions because you have to take like the results and like convert them into something that can be written. Printed to the screen. So I would have to create like some sort of function calling like print traffic to be able to figure out based on whether it's red, yellow, or green, should it return the string of red, yellow, or green. That's assuming I want to do like any kind of bug checking with that type. So keep that in mind. So always be careful, like, you know, not creating types that are going to creating so many types that's going to be really difficult for you to create all the tools you need for bug checking. You know, these are things we take for granted when we are using like languages like Python, JavaScript, and Ruby, where it's just easy to kind of like log any value of any type. But again, you don't necessarily have type checking, so debugging can also sometimes be a bit more torturous in those languages as well. So hopefully you guys enjoyed that, but you guys are starting to get the feel for sort of like what the syntax is like here in OCaml. I'm not gonna go through every feature. OCaml has a lot of features. There's a lot of stuff going on, but hopefully this is giving you an idea. My name is Alex Merced. Have a great day and enjoy.